Hi, hello doers. Welcome to the second module of the FAIR data training for deep ocean early career researchers. Today we'll be talking about collaborating in the research data lifecycle. And for those seeing this recording, the bottom of this first slide has the link to the slide, so you can follow along and click on the links as we go along. Welcome if you are new to the iDOOS project. This is the Implementing a Deep Ocean Observing Strategy project funded by the National Science Foundation. And DOERs more broadly is an international network of deep ocean observing, mapping, and exploration programs endorsed as a UN decade program. So hi, I'm Stace Beaulieu. I'm talking with you today from Woods Hole Oceanographic Institution, Woods Hole, Massachusetts. And during our live session, we'll be joined by Karen, Leslie, and other seafarers in the iDOOS project. And of course, all the doers in the room joining us from around the world. And for those with access to the links, we can read the stories about the many doers in this project. When we get started in the live session, we'll highlight our principles of collaboration, really important today as we'll be talking about collaboration practices. And also I highlight here open science as a concept because we'll be learning a bit more about that in today's module. And in the live session, we'll be using the Zoom teleconferencing platform, and we'll be trying to make this accessible with live transcription and using the reaction buttons and doing a poll, and we'll have breakout rooms. So we look forward to having the live discussion, and that's why I'm recording the slides today so that these are here for your reference. The course as a whole steps through the steps of the research data lifecycle. In module 1, we learned about FAIR data, and I'll recap that shortly. Today, we're going to step into this data lifecycle with the plan, collect, and other steps, and the collaboration tools that we can use to facilitate these steps. This infographic is the result of a collaboration between DOERs and the Earth Science Information Partners, ESIP. And I also provide the link to the full course syllabus here. To recap module 1, we looked at foundational good enough practices in scientific computing. We focused on individuals and how we as individuals are managing our data. That's in contrast to today, we're going to focus on working in a team, working with others. We defined findable, accessible, interoperable, and reusable FAIR data last time, and we'll of course follow up on that today. We had breakout room discussions about data management last time, and we did some homework to find and access data. So you asked for more live real-world examples. We'll have that today, as well as breakouts today. No homework today. In module 1, we introduced a variety of benefits to making research data fair. And here I'm just highlighting in the first module, we focused on the benefits in terms of efficiency, managing our time, and storage of data. Today, we're going to focus on how FAIR data can help improve collaboration, in particular across disciplines. So our breakout rooms will be across discipline. And then in our upcoming modules, we'll talk more about data integration and reusing others' data. So we are focusing on collaboration and FAIR data today. In module 1, we introduced the research data lifecycle, but just very briefly with this slide. This is a wonderful slide from a Carpentries Incubator project, and it shows kind of visually this idea that if you share at each step of the research data lifecycle, ultimately it makes the process more efficient in terms of how you can publish and get credit for your data. And in terms of making data fair, it also is very helpful to think about it at each step along the way, rather than trying to cram it all in at the end. Just from my own, in fact, my own experience, I can tell you it's hard to do at the last minute. What are we going to learn today? I really like this statement. It's from the Cyverse program, which I'll mention a couple times today. The most important thing to remember about data management is that you are not alone. So maybe you felt alone in Module 1, but today in Module 2, you're going to feel like part of a team. We're going to venture into the research data lifecycle. We're going to discuss digital collaboration practices and tools for open data science. We're going to understand how open science practices can facilitate collaboration in science. Remember this concept of open data, and we're going to remember concepts related to the first couple of steps in the research data lifecycle. We're not going to get all the way to apply today in the Bloom's taxonomy, because we only have one session where we decided to just give one session for Module 2 because we got the virtual annual meeting coming up very soon. So today, again, only one session, and we'll spend about 15 minutes in the live session on each of these. We're going to start by giving some examples of, kind of stepping through the research data lifecycle and tools that I personally have used. Then we're going to open a Jamboard. We'll talk about the Jamboard in plenary. Then we're going to talk about our anchoring articles for today. We have 2 anchoring articles in the syllabus. Then we'll go into the breakout rooms. Again, these will be cross-discipline, where we'll be able to discuss which, the Jamboard has several pages, so you'll be able to discuss which you're interested in. And then we'll end with some more concepts of open data as part of open science. The last module, we talked about the Good Enough Practices paper as our anchoring article, and that paper has a section about collaboration, and I pulled out just these 2 sentences that are very relevant today. You may start working on the projects by yourself or with a small group of collaborators, but it's a good practice to design the project, organize the project to make it easy for new collaborators to join. And this is not just new people coming into your lab group, but think about yourself returning to the project after it's been idle for a while. So yes, some altruism, but also it can be selfish. We were selfish in Module 1, but let's be thinking about our collaborators today. So I mentioned the Earth Science Information Partners, or ESIP, earlier, as DOERs collaborated with ESIP to make our infographic for this course. And I was just so surprised. It was so serendipitous that at this January's ESIP meeting, there was a whole session on this topic. And I mean, I had planned this module in our syllabus well ahead. So I was just so pleased to see that a community repository, Dryad, led a session about collaborative support for the data lifecycle. So I'll throw in a couple of slides today from that ESIP session. And within the iDOOS project, we have so many network partners, right? So I've circled a few of the partners that I'll provide examples for today. And I'm assuming that we'll hit on more. So as we have our discussions, we are probably going to touch on many more of the projects and programs involved in iDOOS and the tools that we're using in these. Okay, so I figured I'd start with a real life example that I was involved with. And I'm pulling this, relating back to our homework demonstration from Module 1. So I have this paper linked here in ecology. It is a paper, lead author was an early career researcher, Lauren, who, by the way, has agreed it's okay to show this example. And in our last module, we found and we were able to access the data and code in this paper. But how did that come to be? Like, how did we make these FAIR data and how do we release them to the world? So let's talk a little bit about that today. What collaboration tools enabled these FAIR data? So I'm throwing out here our research data lifecycle, and we'll step through each step here, and I'm mentioning a couple of tools that we used in this project. So we used a tool for the planning step for the data management plan. This is one example tool, so I'll show that on a subsequent slide. In the collect step, we used a number of tools, but the one I'm going to highlight today is Google Sheets. And I'll tell you why on a subsequent slide, why I picked that to highlight today. To process the data, we used a number of programming languages, in this case, R and Python packages, and we used version control, Git as our version control software, and GitHub as the cloud hosting for the code under version control. GitHub I'll highlight today a couple of times. For the describe step, we used a tool from the World Register of Marine Species. And this actually is a tool that, so today we're really going to talk more about general collaboration tools. This taxon matching tool is more domain specific. So I'll save this tool to talk about in the next module. And the next module will really get into, tools used by biologists. In this case, this is used by biologists. In the assure step, we also used some programming languages to clean the data and make sure the data were high quality to submit to a repository. We exposed that code in GitHub Online. And for the preserve step, we basically saved the package of files in Google Drive so that we had one place to go to share all the files associated with the package we submitted to the repository. So for this first tool, the data management planning tool, I'm highlighting a particular template that I used, accessible here from the U.S. Biological and Chemical Oceanography Data Management Office. It's one example template. There are many public templates available in the DMP tool that you could select from. And in our infographic, you can find links to other data management planning tools that step you through basically the sections that you might want to include in your plan to your funding agency when you write your proposal. We're not actually going to do an activity with data management planning because the COBRA Masterclass, I think, has a great activity for that. So I'll let you look to those materials online. But I did want to highlight, because today we're talking about collaboration, within a data management plan, you often have a section for roles and responsibilities. And our infographic has a paper that has 10 simple rules for creating a data management plan. And it includes Rule 9 for roles and responsibilities. And I am really putting myself out here, but I'm actually linking you to the actual data management plan. It's publicly available online for the project that supported those data that we found from the paper. And you'll see this section in which we give roles and responsibilities to each of the PIs in the project. And we talk about how the PIs will engage with repository data managers, as well as an international working group for which we both used and contributed to a database. Moving into the collect step, I thought I'd be remiss if I didn't mention tools that are available to you to share files, right? So we talked so much about file storage and backup in our module 1. I do provide the link to the cloud shared storage, but I mean, I can't even believe how many options there are today. I'm really only familiar myself with just a few of the many file hosting services I found when I went to this Wikipedia page. So I'll only mention a few today. But I do also want to mention at your institution you can check with your IT department or with your library. You may have services available to you at your institution, so you don't have to be limited by a shared cloud storage or have to pay for that. So for the collect step, I said I was going to highlight Google Sheets. Why? Mostly because I really wanted to highlight how this particular international working group used Google Sheets to collect and share data. In this case, it was functional trait data. And I'm citing here the data package published in the Dryad repository. This work was led by an early career researcher, Abby Chapman. I'll give amazing credit to Abby, who set up these Google Sheets, essentially they're spreadsheets on a cloud-hosted server. And they were set up with data validation. These are essentially drop-down lists so that you would be able to harmonize the entries or the values in the spreadsheets. These spreadsheets were shared with edit access to the working group. With edit access, you can go back and you can see the version history of a Google Sheets. So it allowed for us to see versions in a way, but when you open the page, you're just seeing the latest version. And Abby provided video instructions for how to use these. It was just a really impressive use of this online tool to collect a very harmonized set of data from a good number of people. So I also would be remiss if I didn't say that I used the collect step myself in a couple of projects to collect metadata. So previous slide was more actual data tables being collected, and then here I'm highlighting the collection of metadata, which, if you remember from the FAIR principles, is also part of what's important to be fair with the metadata. Here I'm highlighting the use of GitHub, which is a cloud-hosted version control tool, and I wanted to point out that it's not just the version control that got me to adopt GitHub as a tool. It is the ability to use this tool to, it's very visual. You can very quickly see changes, right? So I provide a direct example here from a long-term ecological research project that I'm involved with. And it's just so visual how I can quickly see a change, in this case, a change that's been made to a text file, this being methods included in metadata. And then within, it's not just that you can visually see, it's that you can collaborate. So I learned this through working with the Ocean Observatories Initiative, one of the iDOOS partners. It's so cool how we use GitHub to create, in this case, we're creating a calibration metadata file. And then the person who creates it requests a review from 2 other people on the data team. And then we use the GitHub tool to review. And then ultimately, we allow for, I'll use some jargon here, a pull request to be approved. Ultimately, once approved, this gets pushed all the way up to the main branch for the Ocean Observatories program. So it's a wonderful workflow that you can use with others to approve materials and make them publicly available. So I mentioned that GitHub facilitates this review process for calibration metadata, but I also want to point out that GitHub is being used in other steps in the research data lifecycle by this particular iDOOS partner. And I'll highlight our Mike Vardaro, Seafarer, may be able to join us at the live session. We are also using GitHub to provide our quality control code and thresholds. Okay, so I've pointed to some actual examples in my work of how I use collaboration tools for FAIR data. So now we'll go into a poll. We'll figure out which steps in the research data lifecycle people want to focus on today in their breakout rooms. And also we'll use this to figure out how much time to give each step in the plenary. We will then move into the Jamboard and the plenary. I just have one screenshot here and will help to understand how to use the Jamboard. Retaining some content from the ESIP-DOERs meeting in which we created the infographic, because some tools were mentioned as at that time, and then I'll also highlight the tools in today's module. The next section of the module is going to go into the 2 anchoring articles. The first article, written by Julie Lowndes et al., is allowing you to learn these concepts of open data science, but also kind of think about a way to work in your lab group, to have lab meetings, to talk about data, just to have everyone in the group feel comfortable about talking about data and how to make those data fair and open. The paper is called Supercharge Your Research, a 10-week plan for open data science. And the definition of open data science in this paper blends a definition of data science, loosely turning raw data into understanding, with open science tools and practices, such as collaborative version control. So GitHub is highlighted in this paper. I mentioned it for code and metadata management, and then the paper, and then we'll get into how it can also be used as a tool for project management. The Supercharge paper refers back to an earlier paper, also by Julie Lowndes et al., Our Path to Better Science in Less Time Using Open Data Science Tools. And for the open data science tools that I want to highlight on, well, let's actually have a look at table 1 in that paper. So I'm going online to this Nature, Ecology, and Evolution paper. And although this paper is in a disciplinary journal, you might think it's, related to the biologists in the room, but I'd say these tools and practices are related to everyone in the room. Physicists, chemists, engineers. So this table is wonderful because they show you what tools and processes they used to do in their lab group, and then what they ultimately adopted as a lab group in terms of a practice that made their work more efficient. So they used to have a lot of manual practices, interacting with graphical user interfaces and such. They used to use multiple programming languages. They used to use email to share files. And then when they moved to working together with open data science tools, they found that they could, by the way, not every lab group can converge on one programming language. As you saw in my own work, I use multiple, okay? But in this paper, they found that converging on a particular set of packages in a programming language was useful for them to have efficient workflows. They used a version control software. They used a cloud hosting for that version controlled material. And they did even more with the cloud hosting version control. As I mentioned, they used it for task tracking project management. The idea of hosting version control, again, I'm just highlighting GitHub because it's in my own work and in the paper, but there are many other options. Oh, I need to add a link to the Wikipedia page that shows you more options. In any case, out of the Supercharge paper, we have a wonderful group a community online that you can refer to for their blog and for their lessons. It's called OpenScapes, and this is an infographic on an OpenScapes blog that talks about collaboration as the compelling reason to manage the project with Git and GitHub. And I feel that is what made me move over to this cloud-hosted version control, right? Because I saw how well we could use it in the Ocean Observatory's initiative project. So I'm just giving it as an example of how I've seen success. And in this case, in OpenScapes, they have seen success. but I want to be more broad, right? I don't want to tie anyone into one particular tool. And so our other anchoring article is much more broad in terms of why and how you might want to use tools to collaborate in a team. And this paper is just a great overarching paper of showing why it's useful, in this case, to cultivate transdisciplinary collaboration. And in this sense, what I'm hoping to get the sense is that you can see that collaboration tools, they don't just connect people to people, and they don't just connect people to data. This paper shows you how the tools help connect people to code, data to code, people to people, right? So the rule that I'm going to highlight today is sharing collaboration tools. Of course, I'll also highlight back to why it's important to manage your data. And if you have a chance to read this paper, you'll be able to go through all many other types of practices that you can work on in your team to facilitate the collaboration and efficiency of your workflow. So I went into Rule 6 in the Sane et al. Paper, and I tried to take, I think they had 10 different kind of generic tools listed, and I tried to put those tools into the appropriate or respective step in the research data lifecycle. So I didn't see any tools that matched the plan step, but for the collect and describe step, I noted file sharing, which we've talked about, collaborative documents, we just hit on earlier with Google Sheets, scientific discovery platforms we didn't hit on today, but I mentioned Cyverse earlier. That's an example of platforms set up within a discipline, usually within a discipline. We might hit on some of these in Module 3 in the ocean sciences. For process and assure steps, Sane et al. Highlight computational notebooks. We assuredly will get into that in Module 3, and I had one example with the Argo program in Module 1. Containerization may be a new term to many in the room, and so there's a little asterisk. This is a word describing reproducible and executable software configuration. It's a way to share your software environment so that others can run your code. I don't think we're not actually going to get into that in this training, but I refer to some other resources, for example, through the Cyverse program, so you can learn about that. For the preserve step, Sane et al. Highlight project archives and data repositories as community tools. In this case, the community per se could just be within your lab group, but we could also be more broad with respect to data repositories. For example, going all the way to Dryad or BecoDemo as examples I've mentioned earlier, with tools provided by those repositories. So the Sane et al. Doesn't get into the plan step, but I did want to point out that at the ESIP session led by Dryad, often as a researcher, I admit I don't think of this ahead of time, but it is a great idea to contact librarians at your institution, to contact data managers at the repositories that you're aiming for. When you're writing that data management plan, kind of to just make sure that what you're doing, as I mentioned earlier, doing in your steps along the way will ultimately meet the requirements or the formatting needs or the preferences of the repositories that you're aiming for. And in the collect step, when I saw on the Jamboard from the Dryad session at ESIP, I saw this particular sticky note. Think about who might want to use your data in the future. And that rang a bell because I remembered one of the PIs in the DOERs project saying that to me, that we shouldn't save reuse data to the very last module. We should be inclusive of the reuse step. I haven't mentioned it yet today, but I'm going to start now. There's a great paper written by Diana La Scala Grunwald, who was a former seafarer in iDOOS, that talked about co-designing your data products. In this case, I believe this was kind of generated from an iDOOS provider of data. So, but even as a researcher, an academic researcher, I think it's good to think about who's going to reuse your data as you're collecting it. This is part of what we read about in the FAIR data paper by Wilkinson et al. If you think about it from the early steps in the life cycle, it really helps you make those data fair by the end. And again, we'll get more into the reuse step in Module 4. So the other rule I wanted to highlight in Sane et al. Is manage your data like the collaboration depends on it. So this effort that you put in along the way in the research data lifecycle to make your data fair, in their words, pays off downstream. And there's still an immediate reward, though. Immediate reward to the collaboration is on-demand access as soon as you've processed. So essentially providing access within your project team right at the process step will allow the collaboration to make that data product even better before you get to the, as you move into the assure step. Last in Rule 6 from Sane et al., there was a couple of tools listed that I don't think we've really touched on yet. And I didn't actually think of these as tools to facilitate open data until I thought about it further and how I'm really using these tools in the data teams that I work with. And so these items are the shared calendars, which, by the way, Sane et al. Ties in with to-do lists. So I think of it more as the to-do list as being the important aspect. Instant messaging and video conferencing to make that people-to-people connection. And we're doing some of this, right, in DOOS. Here today, we're using Slack for our data training channel, and we're using Zoom to connect. And this relates back to the Good Enough Practices collaboration section, in which the project, a recommendation is for the project team to decide on communication strategies and create that shared to-do list. And before I ask the other seafarers in the live session other tools, I thought, you know, there's a tool I haven't mentioned yet that I'm using in the data teams that I work with, and that's a Kanban tool. Kanban being a way to display your tasks. You move the tools on the board from to do, doing, finished, and then prioritize the cards. And, you know, it's like what we used to do on a bulletin board, but now we can do them online in a GitHub project board, which is the OpenScapes lesson actually shows you how to do a GitHub project board. And another provider is called Trello. I use that in a couple of projects. In any case, in the live session, I'll move into the seafarers and I'll ask the seafarers in the room if they have any tools that they use when they work with their data that we haven't mentioned yet today. And this will be helpful to make sure we populate those onto our Jamboard as we open the breakout rooms. So in the breakout rooms, I'm referring back to the supercharged paper, and the very first week they ask, what does a team workflow look like for open data science, right? And so this is, how are we using tools to step through that data lifecycle? And so we've already done a poll. We'll probably have rooms associated to different steps. Maybe people want to focus on one step today. Maybe people want to talk about tools used to collaborate across all steps. We'll have rooms open for that, and we'll be able to have discussions so that by the end of the discussion, the Jamboard should have a rich set of tools that the doers across countries in this project globally are using. And I'm hoping to learn new, I'm going to find out about tools that I don't know about yet, and then I can look into them after today's session. We can also share in the Zoom chat, which then I can follow up in the Slack afterwards. How is all of this related to open science? So here I'm providing two actual definitions of open science. The top definition from United Nations UNESCO, and the lower one is from the United States White House Office of Science and Technology Policy. So two different perspectives on how to define open science. I'll read one of these out loud, but you can read them yourself. You have access to the slides. I'll read the UNESCO definition. Open science is defined as an inclusive construct that combines various movements and practices aiming to make multilingual scientific knowledge openly available, accessible, and reusable for everyone to increase scientific collaborations and sharing of information for the benefits of science and society. I chose to read that particular definition because it has a direct connection to the A and the R in FAIR data, accessible and reusable for everyone. In our class, or in our learning here in FAIR data training, we only have time really to get into open data as part of open science. But open science has so many more concepts involved, right? We are focusing today on open data as part of open scientific knowledge. But again, there's so much more involved. And the UNESCO Open Science Toolkit just came out a couple of weeks ago. So I highly recommend going to this toolkit, and it's different. It's a different set of tools than what we were talking about today. Today was really just hands-on tools, interacting with data and how to interact with people on your project team. This is more broad, how to be more inclusive in your team science. And so again, glad to see that that toolkit came out. And I should also point out, I provide a link to the UNESCO recommendation on open science, which has it's actually a really well written document that kind of steps through the variety of practices that you can consider in your research team. Here, I just blew up the top part of the previous diagram to highlight that open data is just part of open science. Providing these learning materials to you online and with a license we'll ultimately publish with is part of this idea of open educational resources for capacity building. And I also want to highlight open hardware as a concept, because we don't have time to get into it in this training, but this concept is related to one of the virtual annual meeting sessions coming up. So if any of you attend the Cheap and Deep Technology Solutions session, co-led by the Ocean Discovery League, that this concept of open design, open hardware, and open source software will be related to that session. I don't want people to think that FAIR equals open, though. So I want to throw out a couple distinctions between FAIR data, as we learned in Module 1, and open data, as we are learning today. I chose just 2 points to make here. This Carpentries Incubator training that I highlight here has a nicely written additional set of points. The 2 points I'll highlight today: if we read closely the original article by Wilkinson et al. That we read in Module 1 about FAIR data principles, the A, accessible, applies to metadata, but access to the data may require authentication. Also, we learned that some data are literally too big, right? Too big to provide that easy access online. So accessible, yes, a landing page saying with information about the data, but it may not necessarily be able to access the data without that login or without a hard drive. Open data that don't follow the FAIR principles may not be F, I, or R. So they may be accessible, but they may not be findable. In other words, you may need to know the link. They may not be interoperable or reusable. So in our modules 3 and 4, we're really going to be focusing on the I and the R so that we can learn more about how to make our data truly fair, not just accessible, not just open. Within the UNESCO recommendation on open science, there's this wonderful sentence I pulled out with regard to building capacity, which we're doing today in this module and in our series for the iDOOS project. Open science really requires investment in building capacity, right? For us all to learn together. And I'm highlighting this phrase, digital collaboration practices, because that's really what we wanted to talk about today. And I hope when we go through the Jamboards, you really feel that you learned about how other peers, mentors are using digital collaboration practices and tools to facilitate our data lifecycle. I'm providing a couple of links to selected resources to learn more, a link to the OpenScapes core lessons, a link to Cyverse lessons, NASA TOPS lessons, and of course the COBRA training that I mentioned earlier. I'm also pointing to a paper that is introducing the CARE principles, which is important for inclusive team science, but we didn't have time today in Module 2 to get into that. Referring back to the infographic, today we touched on the plan and collect steps, mentioned a bit about the process steps, but we'll get more into that in Module 3. And I'm pointing again to the COBRA Masterclass for more activities per se about planning and collecting. We'll end the session with a pulse feedback. We'll see if the learners can understand open science practices, how they facilitate collaboration, whether people remember the concept of open data and concepts related to the plan and collect steps. I'll have people fill out a minute card and say again, we don't have any homework, but I'll leave you with an article that you may be interested in reading prior to the virtual annual meeting. 10 simple rules to cultivate belonging in collaborative data science research teams, new article. I'll be available on the Zoom for follow-up, same time tomorrow after the live session, and I'll post follow-up to the DOERs Slack channel. Acknowledging again our project supported by the U.S. National Science Foundation. The training program was based on a workshop series developed by data professionals at my institution, Woods Hole Oceanographic, with materials available online. And thank you, and